So my name is Nick. I've been doing Kubernetes stuff for about 7, 8 years. Before that, I spent a lot of time in infrastructures. I've been working at Cisco for about 6, 7 years as well. I've been doing a lot of pre-sales, post-sales, solutions architectures, all of that. And today I wanted to present a talk where I can combine all those kind of 20 years of sort of infra experience together with cloud native. To allow you to get into the process of, okay, I want to build a highly available solution in Kubernetes. Where do I start? What are the things we need to do or not do, and different patterns. So I'm going to bring you into this journey. And yeah, if you want to connect with me, you can scan this, but I will also put it in the end. So one thing that is very particular about me, I love coding. And I love to build Rube Goldberg machine. You know, that's this basically very fancy, complex machines to do very simple things, but in a very complex way. And I love this image for Kubernetes because with the advent of microservices, there's this whole story about Kubernetes. Okay, I'm scaling to 10, so therefore I don't need a container. I need Kubernetes because I have to run 10 pods. Obviously not, but at the same thing, it allows you to experience sort of production scenario, even with simple things. So I think I presented this app last year, but it was another scenario. I kind of tweaked it a little bit. So the idea for today is to provide a highly available version of a Dadjoke generator using multiple components that are quite familiar with production system. So the idea is, okay, I'm a user, I want to request a Dadjoke, so of course I need an ingress controller. I need a server to expose the API. So I didn't build any front end because I didn't want to add even more complexity to that. So it's going to be API endpoint. Then I have a joke server. Its role is to serve the joke request, take the joke request, post it, or update if you want, or send it to a messaging message queue. In that case, it's NATS. Then we have, of course, a joke worker. So its job is going to be to take this request and use OpenAI API to generate that jokes. Then out of that is going to store the joke into a MongoDB database server, cache it into Redis, and at the same time, the joke server also provide a rating endpoint that allows you to rate a joke and store it locally in a PVC in JSON format. And the joke worker, once it's served the joke, is going to publish the message on NATS. The joke server gets the joke and send it back to the user, right? So simple things, but very complex way of doing it. So the idea again is to have a 2-cluster scenario. So today we're going to be using AWS EKS, but a lot of the concept I'm going to be talking about are common to all the cloud scenarios and also like on-prem if you have any cluster. So the first thing to cover when you have this in mind is, okay, how do I present my application? What component needs to be local to Kubernetes in terms of DNS, and what components needs to be like either private between the cluster cross-region or completely public. So the idea again is to have 2 Kubernetes cluster and also to be able to present the application on the internet. So there's a couple of things that first we need to do in terms of DNS. We need a private hosted zone for cross-region communication. And we're going to delve a bit deeper into what are the scenarios for cross-region communication a bit later. But first off, we need to populate this private hosted zone with some sort of services in Kubernetes. In particular, because we're going to be using stateful sets, we need to present stateful set and have DNS name from the stateful set into the private hosted zone. So the idea is, how can I do that, right? So we're going to see that with external DNS, what you can do is annotate headless service. Everyone is familiar with headless service for stateful set, okay? So just a quick word, for stateful set, you need a stable name, not IP addresses. So the idea is to provide a very stable name for pods, therefore cluster IP equal none. And the idea is to access individual pod from the stateful set directly. So if you request, you just send a request to the headless service, it's going to send you back all the IP addresses of the individual pods, as opposed to cluster IP that's just going to do load balancing through kubeproxy. Right? That's the main difference. But who cares? The idea here, two things. One, we need to populate the private hosted zone with some DNS names, mainly the MongoDB stateful set. Today we're going to focus, there's a lot of rabbit holes here, but for today we're going to focus on MongoDB because this is the part that is really critical to our application, and this is what we want to make highly available across different regions. So because we have this private zone, it also means that to resolve to resolve from the name to IP addresses from that zone, within every cluster, what do we have to do? We have a local DNS server, which is core DNS. Therefore, we have to create first a config map for a custom config map for core DNS so that we can enable a forwarder saying, okay, the name of our private zone is internal.k8sdr.com. So the idea here is to forward to the VPC resolver in AWS, which is always, I think it's .2 from every subnet. So it's quite predictable, but same in any cloud, same in your private environment. Basically, you put your forwarder, you put it here. And so we have two sites today. We have West Europe and South Europe. So it's going to be Milan, which is going to be our primary site, and Dublin, which is going to be our secondary site. And the idea is to have, so we have core DNS here, as you can see, and then our MongoDB will have 3 nodes in Milan and 2 nodes into Dublin. And the idea is to have, if you know how, and again, we're going to talk about, is MongoDB a really good decision for that? But for the moment, let's focus on MongoDB. We're going to build a single replica set across multiple regions. So we have 1 write replica, and we're going to have 4 reads. So the write replica is going to be in Milan, and the read replica are all the others, which means that if our front end is in Milan, it's going to write into Milan. If our front end we want to reach is in Dublin, then it's going to also write first in Milan, right? So we're going to see what we want to enable and how we can limit the cross-region sort of writes. So, and the only thing you need to do basically to get your private hosted zone automatically populated is to annotate the headless service with this particular annotation. So external DNS, blah, 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 and then host name, the name of the zone. So one specific, so milan.mongodb.internal.k8sdr and dublin.mongodb.internal.k8sdr. And if you do just that, automatically, external DNS is going to populate the DNS private zone with every pod from every cluster, right? So we have on the top automatically mongodb.milan and mongodb.dublin that we're not going to be using. And then we have every individual pod, right? So it's compatible with a lot of different DNS, a lot of different clouds. So external DNS is really a no-brainer. So again, why we need that? Because for some situation that are not local to our cluster, we want to reach out to other components that are in the other cluster. Okay. So now for our global traffic management, how do we make our application available from the internet? Well, the idea is to have a single DNS name that then, depending on the health check of your different ingress, actually, right? Remember, we have ingress. We want to see the health check of the ingress. So it's actually a chain, right? So we want to use a global DNS, single DNS that will check back to the front end and to the back end what is available on which site, and depending on the results of the health check, then redirect to one site or another, but the fastest possible with predictable name and IP addresses that never changes. So with Global Accelerator in AWS, you have the same thing, in GKE, in every cloud. The idea is that at the edge of the network, you provide an anycast set of IP addresses, which means they are static. They are predefined. You have one DNS name that maps to those IP addresses. And behind the global accelerator, you're going to have the two ingress controller, one per cluster. And depending on the health check, the global accelerator will be able to redirect you either on the primary website, primary site, or to the secondary in about 30 seconds, and you don't have to think about anything else. And again, because it's a single anycast IP, which means it's always the same IP, you don't have any DNS caching or TTL problem because it's always the same IP, so you always resort to the same IP. Now, in terms of cross-region discovery, again, I've just said that we need core DNS forwarding, we need the private hosted zone, and of course, we need to override the minimum TTL for our local core DNS for faster in-cluster resolution, right? So reduce, but that's specifically for our local cluster. So now another question is what load balancer do I make public? What load balancer should be private? So of course here is just a basic diagram. We use Route 53 for DNS, of course, the global accelerator. And in the AWS, we have two types of subnets. So we have the ALB. So ALB, think about ingress. Ingress, public IP, public subnet, as easy as that. So it's going to be sitting in our public subnet. Then we have our NAT gateway. So that's our node can access to the internet. Same thing probably everywhere, also public subnet. Private subnets, well, this is where we have our internal load balancer. So internal load balancer, think service type load balancer inside Kubernetes for internal communication. So I'm going to tell you in a minute why we need that, what situation, so ALB versus NLB, or external versus internal, same thing in a private data center. And of course, we need peering connection and peer those two VPCs so that the clusters can talk together. And again, remember, one of the primary promise of Kubernetes is that every pod is directly routable in a cluster and within your private environment. So by peering to VPCs, I can make, first off, pod-to-pod communication through IP address. And then with the private zone via resolution, cross-cluster, I can not only communicate via IP routing, but also I can identify and resolve pod through our private hosted zone. Now, the possible traffic flows. This is what is going to be constrained by our application. So first off, as I said, you are a user. So we start at the lower end, left side. So we have our user. It's reaching, or she's reaching, not it. It's not a dog. We have our global accelerator name. You can customize it with your own internet domain. But yeah, because I'm paying for this environment and you don't want to pay extra, so it's just this fancy name, right? But again, the point it's stable, right? Stable DNS, always the same IP. And again, global accelerator allows you to create two listeners. So public load balancer, ALBs, ingress. So we have two ingress. Again, one in Milan, primary, secondary in Dublin. And the idea is to monitor /health directly from our front end, so from our Dadjoke server, which is our front end. But remember, we're going to talk a little bit about that, but the endpoint, the health endpoint on your application should not be like 200 OK by default if the app is up. Why? Because if you have another component, like a database in our case, if the database is not responding, how do you bubble this up to a global accelerator or to other monitoring system? You cannot. So the best practice when you build health endpoint is really to take care of all the, let's say, downstream dependencies so that you expose the 200 OK only if you can connect to your depending services. Otherwise, it doesn't make sense, right? And because we have global accelerators, ALB, so ingress to our Dadjoke server to the database, just with this little health endpoint API, we can expose whatever issue that may arise, and then global accelerator by default is going to switch to the other side. Very simple. And it's done automatically. So again, ALB ingress provisioning, we're going to see in a minute. Just annotate a particular service. For NLB, same thing, just annotate service. So the good thing with Kubernetes, if you have any cloud automation, or if you are using like a MetalLB or any sort of a plugin to automate load balancing, then it makes things a lot easier. So here, there's a lot of different paths. Let's say in a nominal path, like everything is going right, we have 100% of the weight that is going to our ALB into Milan. Then that the ingress going to Joke server is connecting to our MongoDB through a service type load balancer. So why going through an NLB? Again, the NLB is exposing a stable DNS name, right? So if you don't, because we have this private zone with all the DNS name, the FQDN available for all the pod, we could eventually, instead of using NLB, directly expose the name or the IP of the pods because it's a stateful set. But even with a stateful set, IP address can change, and we are relying then on DNS, TTL, all that. So we want to avoid that. Therefore, NLB is the simplest solution, and you expose this NLB to the connection string, right, of the database. But we're going to talk about this a bit later. But the idea is that use NLB as a simple way to make your connection kind of stable, and yeah, in a sense, you can trust it. So Joke server is going to talk to MongoDB via the connection string, and we're going to go deeper into what is the connection string a bit later. And again, NLB auto-generated, ALB auto-generated. So this is kind of a given. So for east-west traffic, again, meaning pod to pod or DB to DB connectivity, because remember, we are replicating across region. We have a single replica set between MongoDB nodes. Therefore, we need to talk together. Everyone, it's like a full mesh, right? So the idea of the replica set, you define in Milan who you need to talk to, and Dublin who you need to talk to. So locally, let's say if I'm in Milan, then the idea is I'm going to use the local Kubernetes, core DNS server. Therefore, I'm going to use all the svc.cluster.local individual pod. It's easier. Then, if via the headless service, and if I need to talk to my other MongoDB member, so again from MongoDB to MongoDB for replication, to reach the other guys, the only way again is using the private hosted zone. And because it's Mongo to Mongo, I cannot use NLB for that. I need to address the pod specifically. So again, this is why we have this external DNS that populates for every pod. We have the entry into the private zone, making it reachable from Milan to Dublin, and the opposite way as well, right? So per pod record, no NLB direct. So north-south, which is more out Joke server to the database. Then this is where we use the NLB. Again, you annotate the service with service type load balancer, one NLB per region, and it's exposed via either private zone, but typically here, this is not what I've done. You can do it, but by default, remember, it's connected private. So NLB has all the network connection privately. It's also automatically exposed in AWS in a DNS zone that belongs to AWS. So you will see like the name of the region .aws.com. It's local, meaning that it's not reachable from the internet. And you're going to be using this into the connection string for remote reachability. So for every connection string, so remember, we have two things. We have replication, pod to pod communication, database to database, pod communication. And then we have application to database. So Joke to database. Joke to database, we can use the NLB. It's actually best practice because again, stable IP, if you change the IP address, no need for TTL, which means that in the connection string, locally on the site, we're going to populate the connection string with local server, but for anything remote, so that I can connect locally and also remotely, I'm going to populate the connection string with the remote NLB DS name. So in Milan, remote NLB to Dublin. And in Dublin, I will have local and also point to the NAB that is remote in Milan, right? So kind of reversed. And then we have the ALB again, is just the ingress controller for north-south. So between the user and essentially the front end. So now, in terms of failure, what's going to happen? First scenario, I've got failure from all my front-end pods. Doesn't really matter. So it probably is going to, this is a scenario where I don't want to recover my entire database. So I want to, it doesn't really matter in that case. I don't want to recover everything and promote manually. So what I can afford, so for sure, the health check is going to fail. So the global accelerator is going to redirect the traffic and promote the secondary, so Dublin site. Then Dublin is going to talk to Joke server via the ingress. Joke server, then remember, we have connection string. I've got access to both sides. We have the right replica that is in Milan. So it's going to be using the NLB and NLB to MongoDB. And MongoDB, again, like we are replicating a bit everywhere. Alternatively, I can also promote manually the site in Dublin and kind of promote a write here. And then, but the problem is if I do that, what's going to happen when the server goes back on the left side? I have to replicate again. It's a bit of a, overcomplicated thing. If the only thing that I've lost is basically my front end, which just, stateless information or just the rating, which is not essential to my application. So the idea is, okay, we can afford a bit of latency and cross-zone communication in that case. So what happened is the full site, the full region goes off. Then again, very easy, right? I mean, very easy. But the global accelerator, again, is going to detect that it's failing. The health check is failing. So it's going to go to ALB, ingress, but then it's up to me. I can automate it if I want by just using Prometheus or anything and just run the RS, so the replica set command to promote a write in the sites, at Dublin site. But again, when the other side comes up, I will have to do some manual action. But here is very critical. Therefore, I can basically promote my database at the disaster recovery site. Okay, so this is basically what I've mentioned, just to go through it. So the failover pattern, the primary region, it serves all the traffic by default. The app connection strings point at Milan NLB with fallback to Dublin NLB. That can be promoted as well. The secondary region, so Dublin, you want also to keep the cost minimum. So this is where you want something a bit automatic. If you don't want to run the front end there by default, because normally you should never go there, except if you have an issue. What you want to do is, in case of issue, then if you see a request coming to you via the global accelerators, maybe you just want one replica, because the problem, if you have 0 replica, the health check will be not working and it's a black hole. So you may want just one replica, and based on that have VPA, HPA, KDA kicks in, and then you're going to be able to scale and basically scale your application to serve the demand. Of course, you can use VPA, HPA, KDA, bin packing, some spots, instances, node scaling and optimization. This is one you may want to use something like scale-ups that's going to be, kind of putting some intelligence into managing the whole cluster and how it's automatically provisioned for the right size for the limit, the request, and the nodes, Carpenter, etc. So this is a consideration. Some, again, fail a health check. If this is on Milan, then nothing to do, the global accelerator, flip to the ingress, and the app connection string, because it has both Milan and Dublin, then that's fine. It's going to continue to write to the main site, to Milan. If the full site fails, again, you promote the entire DB in Dublin. And the beauty of that, if you do it this way, because you have stable IP addresses and names everywhere, there's no notion of cache and TTL. Everything is almost instantaneous. I mean, 30 seconds, but it's not related to DNS. Um, uh, yeah, and basically the trade-off here is, okay, I don't want to use maybe external DNS. If I don't want to use that, you can use infrastructure as code if everything is static and populate the private zone. But to be honest, external DNS is a no-brainer. It makes life a lot easier. So this is what I've covered already. In terms of replication, this is the architecture we are looking at. So one write replica and the other reads a bit everywhere. And also in terms of RPO, RTO, so remember, RPO is the recovery point objective. It's how much data you can lose. RTO, recovery time objective, which is the time that you're going to spend restoring things. So usually on top of the MongoDB replication, you want some sort of global snapshotting using Velero, using EBS snapshots so that you can recover easily, right? If the MongoDB replica is not enough. Now some architecture decision trades-off. Is MongoDB the right tool or the right database for that? Again, we have some cross-region traffic. It's not really microservices by definition. Every service should be sort of independent from each other. So there are solutions with MongoDB to have like global cluster and smarter replication so that you don't end up with cross-region traffic. But you really have to start designing your application maybe by using asynchronous pattern, things like more message queues, like event-driven, and what we call hydration and denormalization, which means essentially have a database for write, an event bridge, post what is written, and populate a database for read via the event system, and then you have all the read from that database. So something like more, Netflix is doing, but again, it depends on your needs. How much time do I have? 5 minutes, something like that? 3 minutes. So I wanted to do a quick demo of that, but that's cheating because I started late. Okay, so I'm going to see what I can do in 3 minutes. So normally, so this is my application. I'm in Milan, so you can see Joke server, Joke worker, the database. The first thing I'm going to do is verify that this is my, you can see, good? Okay. This is my global accelerator, normal traffic, okay. You can see region, Milan here, right? So what I'm going to do, because I only have 3 minutes, I'm just going to kill the database. So remember, what I want to show here is the power of the health endpoint. So what I'm expecting, just I'm telling you in case it doesn't work, is that by deleting, or I'm going to put the replica 0 to the database, to the stateful set, right? So the ID is scales to 0. It doesn't respond anymore to the joke server, or joke worker on joke server. Yeah, joke server request. Therefore, the health endpoint on joke server, because it's testing the connection to the database, is going to bubble up this failure to global accelerator, and global accelerator should switch to Dublin instantly. I mean, instantly, we're going to see. So let's edit so stateful set, right? So this is my MongoDB stateful set. I'm going to look for replica here. I'm going to move from 3 to 0 and pray God. So it's going to take maybe more than 3 minutes. I don't know. We're going to see, because remember, what I can mention here in the meantime is that why it's not terminating all MongoDB at the same time. It's because it's a stateful set. So a stateful set, because it's stable, it's Kubernetes is going to terminate the stateful set in the reverted order that it's deployed. So typically it's going to MongoDB -2, -1, -0. So normally, so here I've got the script that is kind of promoting the database at the destination. So therefore, I should be able to still write to my secondary website. So here, what I'm essentially simulating is a full disaster recovery. Now, with the only trick that I have only one replica for joke server and joke worker. So I don't need to scale up because it's a simple, I don't have a lot of load in this application. But what you want to do is at the destination have some sort of VPA, HPA, again, K8spocalypse or whatever solution. I mean K8spocalypse because I work for them, so it's better. 2 minutes, so it's not too bad. Okay, so now I should see, so joke server, you can see now it's also red because it cannot talk to the database. So now in my global accelerator here, I should see, not LC, so here, so EU South 1, which is Milan, my first site, I should see unhealthy. So unhealthy means that it's going to switch to the other ingress, and now automatically, if I can take a little bit of time, if I do the same thing again, you should see doubling in the request, right? I didn't change the DNS name or anything. Dublin. Woo-hoo-hoo. So yeah, it worked. Thank you. All right. So just a couple of things. I think demo time. If you want to connect with me, and if you have ideas, questions after this event, feel free to contact me.